Hello everyone, hope you are doing good. It's been 2 months, so I thought that let me show my face to all of you. Okay, jokes apart. So, since 2 months in this lockdown period, we have been covering the motor system, right? And we are at the end of the motor system. Hopefully, today will be the last class. And this class will be, I guess, the most interesting class in the motor system because this is regarding the applied aspect or the clinical significance. Now, whatever we have learned, the basic part, we will correlate it clinically. Okay, so that will be more interesting. So, in the motor system, the descending tract, there are broadly or largely we can say two tracks. One is pyramidal tract, pyramidal system, not the the pyramidal tract or the pyramidal system. Okay, the second one is extrapyramidal system. Okay, now a bit about these things, the pyramidal and extrapyramidal. What are the pyramidal tracts? The corticospinal tract and corticobulbar tract, right? There is no need to repeat it again and again. Corticospinal is from the cortex to the spinal cord, and corticobulbar is from the cortex to the nuclei within the brainstem, the cranial nerve nuclei. They form pyramidal tract. Extrapyramidal, there are so many tracts that come apart from these. All the descending tracts are called as extrapyramidal. There are so many extrapyramidal systems, but of the major concern, we will focus on three. One is vestibulospinal tract. The other one is reticulospinal tract. Okay, and third one is rubrospinal tract. Rubrospinal tract. These three. Now, all these tracts, whether the pyramidal or the extrapyramidal, they are called as upper motor neuron because they are coming from the upper side, upper motor neuron. Now, a bit about these things. This corticospinal tract, this helps in performing the voluntary movement. All these upper motor neurons are involved. They will take part in voluntary movement to take place. And how they will take part? By controlling, by controlling the lower motor neuron. Now, what are the lower motor neuron? If I try to draw the diagram of the spinal cord, like say this is the spinal cord and this one is dorsal root and this part is ventral. So a simple stretch reflex. Okay, simple stretch reflex. What happens in the simple stretch reflex? Say this is the muscle. This is the muscle. You are hitting it with the tendon, knee jerk reflex, right? If you can recall back, what will happen? Who will carry the sensation? The 1A afferent fiber through the dorsal root, right? From the muscle spindle. Now, they will form the synapse with whom? They will form the synapse with the alpha motor neuron, or there might be gamma motor neuron. Alpha motor neuron and gamma motor neuron. Gamma motor neuron is, that's a different part. Alpha motor, just remember the alpha motor neuron. So this is a simple stretch reflex. Now, this motor neuron, whether the alpha or the gamma motor neuron, which is directly ending over the skeletal system, this is called as lower motor neuron. So, if a simple reflex has to happen, there is no involvement of upper motor. Upper motor involvement is there that will control, but a basic one, the lower motor neuron will automatically do the reflex. But when we have to perform a voluntary movement, ultimate effector system is the skeletal muscle. All the information will be relayed via the lower motor neuron, but upper motor neuron will also involve. So, in the performance of the voluntary movement, upper motor neuron and lower motor neuron both are involved. But in the case of the reflex activity, it can do only by the lower motor neuron. Okay, right. Now, if a little bit about all these things, the corticospinal tract. Corticospinal tract, it takes some time for the myelination after the birth. These fibers, these tracts, they are myelinated. So myelination will happen by the age of 1 year. 1 year. Okay. And in the old age, this myelination will, due to the degeneration, the aging effect, there will be the wear and tear, there will be the demyelination. Because the demyelination is happening of these corticospinal tracts, that's why the older people, they cannot perform any motor activity as fine as an adult can do. That's why there will be some sort of the jerk or some sort of the inhibition kind of the things, tremor. That's the reason, because with age, corticospinal tract demyelination will happen due to the wear and tear. Now, this reticulospinal tract and ruprospinal tract, we need to know a bit about these two. Now, what is the, okay, I will cover this thing and clean this thing up. The reticular formation, the reticulospinal tract we will cover first. This reticulospinal tract is coming from reticular formation, and as you know, the reticular formation is present in the pons as well as in the medulla. So these reticulospinal tract, they are of two types. One is medial reticulospinal tract. The other one is the lateral one. Okay, lateral reticulospinal tract. And there is basic difference between these two. The medial one, it originates from almost upper pons, entire of the upper pons. Okay, upper pons, not the entire of the upper pons. And this lateral reticulospinal tract, it mainly originates from the reticular formation that is present in medial medulla. Medial medullary reticular formation gives rise to these lateral reticulospinal tract. Okay, now out of these two, one is facilitatory and the other one is inhibitory. Means facilitatory and inhibitory to the gamma motor neuron. Okay, to the gamma motor neuron. Now this medial reticulospinal tract, it is facilitatory. It facilitates, right? It facilitates the activity of gamma motor neuron. Okay, and this lateral one, the lateral reticulospinal tract, which is originating from the medial medullary reticular formation, this is inhibitory. And the important point is both of these tracts, they mainly affect the axial skeletal because they help in posture maintenance. So the axial skeletal muscle as well as mostly the extensor, that's the important. There are few of the cardinal points regarding this neurology, and these are the high yield points. You need to remember these things. The reticulospinal tract, they are mainly concerned with extensor. It's not like they don't involve the flexor one, but majority to the extensor muscles. Okay, extensor muscle, extensor group of the muscles. Now out of these, I said one is facilitatory and other one is inhibitory. This facilitatory one is the one that originates from the pons, the medial reticulospinal tract. This one is facilitatory to the gamma motor neuron of extensor, and this one is inhibitory to the gamma motor neuron of extensor. Now let me try to draw a diagram, a flow chart kind of a thing. If you can recall back, what is the gamma motor neuron doing? Just remember, first let me cover this thing, then we will cover that part. The one that is coming from the upper pons, that is called as medial reticulospinal tract. It is facilitatory to gamma motor neuron of extensor group of the muscle, medial reticulospinal tract. Lateral reticulospinal tract, which originates, see, don't get confused, lateral and medial. Lateral reticulospinal tract, it originates from the medial medullary reticular formation, right? It's a bit of confusing. So medial is not the medial, and this one is rest of the reticular formation that is present in the upper pons, and this one is inhibitory to the same gamma motor neuron of the extensor group. So there is a maintenance of the balance. That balance act, that's one salient feature. What is the second salient feature on the high yield point? These neurons, they are spontaneously discharging. They are spontaneously discharging. If they don't have any upper control, still they will keep on exciting the gamma motor neuron. Right? These one, they do not have the spontaneous discharge. They need a control from the upper one. Now, what is the control of the upper one? Upper one is cerebral cortex, cerebellum, basal ganglia, vestibular nuclei. Mainly, we will this part is not covered by those things, so we will just take, we won't go into detail, the cerebral cortex and cerebellum. Cerebral cortex and the cerebellum, the tracts, those, see, they are extrapyramidal, reticulospinal tract. So the tracts coming from this cerebral cortex is corticospinal tract. These are the corticobulbar. So we can say corticobulbospinal tract, reticulo, right? So the tract, which the neuron which is coming from the cerebral cortex, either to the medial reticulospinal tract or to the lateral reticulospinal tract, both of them they will excite because they are the same one. They are exciting. So if it excites the already exciting, there will be maximum excitation of the gamma motor neuron. They will excite the neurons forming lateral reticulospinal tract, which in turn will inhibit the gamma motor neuron. And what is the gamma motor neuron doing? Now comes into play. What is the gamma motor neuron doing? I'll just quickly tell you. These are the muscle, like the muscle spindle, right? And I'll try to draw the muscle spindle with this orange color. Okay, orange color. These are the intrafusal fiber that's forming muscle spindle, and this blue one is extrafusal fiber. So when we were hitting, we were striking the tendon, what was happening? These muscle spindle fibers, 1A fiber, they were carrying the sensation, okay, sensory fiber, right? They were carrying the sensory, and which in turn was forming synapse with the alpha motor neuron. What was alpha motor neuron doing? It was ending on the extrafusal fiber. It was ending on the extrafusal fiber and making the muscle contract. Now, the gamma motor neuron are ending on the contractile end of the muscle spindle. Contractile end of the muscle spindle. So, gamma motor neuron, if the gamma motor neuron discharge is happening, then what will happen? They will make these polar ends of the muscle spindle to contract. If it contracts, what will happen to the central part? Contraction, stretching this part this way, stretching this part this way. So it will stretch more. So there will be more and more stimulation. So that's why there was alpha gamma loop that we have covered in the previous classes. Okay, you can go back to the videos and watch that alpha gamma coactivation was happening. So if the gamma motor neuron discharge is more excited, then there will be more and more contraction, right? And it's not like alpha motor is not acting, but ultimately alpha motor neuron is contracting the extrafusal fiber, but gamma motor neuron is in a turn facilitating that contraction more and more. Like if there was no gamma motor neuron, what will happen? We will strike the tendon, there will be the stretching, sensation will go, alpha motor neuron will get excited, it will contact the extrafusal fiber, it will end up over there, right? But there are the gamma motor neuron. Now the gamma motor neuron, they are also getting some branches from the interneuron or from the higher center. From the higher center, because these reticulospinal tract, they are spontaneously discharging, they are spontaneously stimulating these things, gamma motor neuron. So what will happen? Gamma motor neuron will stretch more spindle. So more excitation and more contraction, it will keep on going, right? So that is how these reticulospinal tract controls the tone of the muscle, tone of the extensor muscle, that these are the muscles, anti-gravity muscles, they maintain the posture. They maintain the posture. Now, what will happen if we cut off this connection? If this connection gets cut off, what will happen? There won't be any inhibition of the gamma motor neuron. There will be stimulation of the gamma motor neuron. Previously, in a normal intact person who is not having any issue with the higher center, there was balance maintenance, right? But when we cut these things off, then there will be more and more gamma motor neuron. So that's why now we will, in the coming video, we will talk about, or after a few minutes, we will talk about what will happen in the upper motor neuron lesion. Upper motor neuron lesion will lead to hyperreflexia. Hyperreflexia. And this is the reason why there will be the hyperreflexia, because this inhibitory one, it was stimulating the inhibitory, this inhibitory one is cut off. Right? Now, before going into that part, hyperreflexia, that I will explain. It will hyperreflexia for the deep tendon reflexes, but the superficial will be lost. That we will also cover. Okay, so before going into that thing, now we know about the reticulospinal tract. Now, the second thing is rubrospinal tract. This is also very peculiar thing. Rubrospinal tract is totally opposite of the reticulospinal tract. Means reticulospinal tract is going to the extensor muscle. Rubrospinal tract. Rubro means red nucleus. Okay, red nucleus in the midbrain. So the rubrospinal tract, it originates from the red nucleus in midbrain. And instead of the extensor, it goes to the flexors. And it's not very well developed in human being. It's well developed in the four-legged animals. Right? That's also a very high yield point to remember. It goes to the flexor muscle. Okay, and it is facilitatory for the flexor muscle, right? It is facilitatory for the flexor muscle. Okay, and how it facilitates the flexor muscle? It facilitates through the alpha motor neuron of flexor muscles. And it's not very well developed in human being, and it doesn't extend the entire of the spinal cord. It mainly ends up at C3 or C4 level, upper cervical level. So it will mainly affect, we can say, the rubrospinal tract will stimulate the alpha motor neuron of the flexor muscle of the upper limb. Okay, that is the only thing that you need to remember about the rubrospinal tract. Rubrospinal tract not very well developed in human being, but still there is some development. It doesn't travel throughout the spinal cord. It ends up in upper cervical part. It supplies the flexor muscles, stimulates the alpha motor neuron flexor muscle. So via the rubrospinal tract, there will be flexion of the upper limb. Flexion of the upper limb. It has also got control from the higher center. And what is that external control? That external control from the higher center, cerebral cortex and cerebellum, is excitatory, right? Excitatory. So that is the second thing, the rubrospinal tract. The third one is vestibulospinal tract. Vestibular, there are lateral and the medial. We will just talk about the lateral vestibulospinal tract, because the medial is concerned with the eye movement and head movement, neck and all those neck tonic reflexes that we won't cover today. Okay, so the lateral vestibulospinal tract. Through the lateral vestibulospinal tract, cerebellum controls the axis, the axial skeleton, and the proximal neurology. There is one more cardinal rule of the neurology, that is the inhibitory. If, like we say, the cerebral cortex or the cerebellum has been removed, that we call it as suprasegmental. If we remove that suprasegmental part, then the effect of the loss of inhibition will be more. Loss of inhibition will be more as compared to the loss of the stimulation. That is the cardinal rule of the neurology. That's why if there is any defect or any lesion within the upper motor neuron, that loss of inhibition will be more, there will be more excitation. Okay. The